Doctors say you should poop at least once every 3 days. If you're keeping a diary of your pooping, you'll want to know how many days you pooped in a month, your poop count. In this video I'll show you how to calculate this statistic at high speed using your C compiler's popcont intrinsic. Let's start with the noob algorithm. We'll represent the calendar as an array of integers, indexed by the day of the month. That means the array will need 32 elements, and we'll ignore the 0th element, since there's no 0th day of the month. Now we'll write a function that iterates over the array and counts the number of days when you pooped. Easy enough. Okay, let's benchmark this. I'm timing how long it takes to calculate a billion poop counts on an Intel Mac. While we're waiting, consider subscribing to my channel if you like this video. And it took about 8.5 seconds of user mode time, so that's about 115 million poop counts per second. Many programmers might be satisfied with this performance. The haters will say you can't do better than the compiler. Nonsense. We can do much better. Let's optimize this. The first thing to do is to reconsider our data structure. Our array of ints is 128 bytes, which is kinda big. There are up to 31 days in a month, and we only care about whether we poop or not on each day. It doesn't matter if it's a big poop or a little poop. If you poop 2 or 3 times in the same day, it doesn't matter, just that you pooped it all that day. So we could make this an array of booleans instead of integers. The bool type is 8 bits. An array of them would fit in a single cache line. Even better is to just work in bits. A whole month of pooping can fit in just one 32-bit register. That's a lot better than 128 bytes. Our code shouldn't have any memory bottlenecks. We calculate the poop count as before, but instead of dereferencing array elements, we'll mask bits out of the bit field. Let's see how much this improves performance. By the way, I should explain how I'm benchmarking. I'm compiling my code using Clang with O3 and march equals native. The compiler should now be taking advantage of all the CPU features like vectorized instructions. I'm also taking care to make sure I am feeding in unpredictable data to the poop count function. If I just call my function a billion times in a loop with the same input, the compiler will just optimize that down to a single iteration. The randomness of the inputs also affects the performance of the CPU's branch predictor. Generating random numbers is pretty slow compared to the function I'm benchmarking. As a compromise, I'm randomizing the data initially, and then modifying the input data based on the pop count output. This is not extremely rigorous, but it's enough to introduce a dependency chain and to hopefully get a fair enough benchmark for comparing performance. Okay, let's run a benchmark. Another thing to look at is user mode versus kernel mode time. The code we are optimizing doesn't make any system calls, so we are going to look at the user time. The system time comes from printing the progress bar and background activity, so we can ignore it. It turns out using the bit field is about 9% faster. Honestly, I was expecting a little better. Let's look at the assembly Clang generated, using objdump. Wow, that's some hardcore vector instructions. Even though the input number is 32 bits, Clang is using 256-bit YMM registers to do some big brain computation. Over at godbolt.org, you can see what other compilers generate. GCC seems to have a similar approach. I can hear the haters now. Look at all that fancy disassembly. There's no way you're smarter than the compiler. Don't be intimidated. Arm yourself with knowledge. A good resource is your compiler's documentation. It's a good idea to be familiar with some of the built-in intrinsics. These can give you access to CPU instructions without having to write any assembly. And they're portable. The built-ins are compiled for each target architecture. You don't even need to include anything. Today we are going to use the built-in popcount intrinsic. This calculates the number of 1 bits in an integer. On x86 this compiles to the popcnt instruction on pretty much any Intel CPU that's not an antique. So we can replace our 32 iteration loop with a single instruction that runs in 3 cycles. Let's benchmark it. Now we're talking over a billion poop counts per second, 8.8 times faster than the noob function. That's an order of magnitude. I hope you found this helpful. I'll leave you with these thoughts. Benchmark your code. Make sure you're doing a fair test. Think carefully about your data types and structures. Study up on compiler intrinsics. The payoff can be much faster code. In future videos I'll talk about some other x86 intrinsics and C code optimization tricks. Until then, don't forget to eat plenty of fiber.